let us treat moving or magnetic force on a moving charge. Magnetic what? Magnetic force on a moving charge. So let us look at what? Magnetic force on a moving what? On a moving charge. So when a charged particle moves through a magnetic field, it will experience a force called magnetic force. Yes? When a what? A charge particle move move through a magnetic field, so what? It experience a what? Experience a force. A what? A force known as magnetic force. So when a what? A charged particle moves through a magnetic what? Magnetic field. It will experience the what? Magnetic force. And the magnitude of the magnetic force is depend on three quantity. Yes? So what? The magnitude of what? No, what? The magnitude of magnetic force. Force depends on the following. What are they? The first one is electric charge. Sorry, is charge. What is what? Is charge Q. Is charge what? Q. Let me charge Q. The second one is what? Its velocity. V. The third one is the what? Magnetic field strength. Magnetic field strength. This magnetic field strength is also called what? Magnetic flux density, which is known as what? B. The last one is the angle between magnetic field strength and velocity. The what? The angle between, which is theta, the angle, sorry, theta between the what? Magnetic field strength B and its velocity, which is what? V. For that case, we can have, yes, this is it. We can have it in this form. Yeah, this perpendicular line, this one represents magnetic what? Force. This is what? Magnetic what? Force in Newton. And this is represent B. B is magnetic flux density. B is magnetic flux density. And yeah, at this point here, we have what? Forget the positive charge here, Q, and right here, like this is what? Soon the velocity, the yes, velocity of moving charge, and this is the angle where the angle what? Theta form. So from this sketch above, we can derive that what our magnetic force is the product of Q times B times what? The velocity. Guess what? Sine theta. With this angle, you can later have it in this form as what? F what? Q BV sine what? Sine theta. You can call this what? Equation what? Equation 1 for this expression. And this, yes, you call it what? This is what? Equation what? Equation 1. And this equation can also exist in different what? In different form. It depends on, let me say, in 4 cases. Let me explain the cases of the equation. Cases. I can group the cases what? Special cases of what? Special cases. Yes. The first one, I will call it case what? Case 1. This is case what? Case 1 on it. What is the case 1 said? He said when the direction of motion, which is velocity, of charge is parallel, it's parallel and the same direction to the magnetic field. That's what case 1. It says that is what when case 1 that when the direction of motion of what? Motion of the charge of the what? Of the charge, yes, of the charge is parallel and the same direction with magnetic fields. Magnetic what? Fields. Line. Magnetic field line. To happen. Look at this case. Let me say this is what? Magnetic bar. This is what? Magnetic what? Bar. The bar always have 2 ends. This end here is north, this end is south. Good. If this is the what? The feed line, this is the feed line, this is magnetic feed line. And if I place my charge inside here, okay, and this is the charge here. So if this charge travel the same what? Direction, velocity, this is the V, this is the direction of what? The magnetic field in this line. You can observe that what? Here, the charge we have here is the same direction with what? With magnetic what? Magnetic field. The charge is the same direction with what? Magnetic field. If is this have it in this form, it tells us that what? Our angle theta here, that is angle theta is equal to the what? 0. Two of them are parallel. And the angle between the what? The two parallel lines is what? Is 0. So we can now say what? From this my beautiful formula of magnetic what? Force is this. We can now have what? Magnetic force should be equal to what? Q B V sine 0. Abi, theta is 0. So if you put it there, the final answer here will be what? 0. That is the force, magnetic force is equal to the what? 0. Whenever the direction of motion of charge is parallel and same direction with magnetic field line, what is what? Magnetic force. Magnetic force will be what? 0. Please note it. The second case is this, case 2. When, case 2, you can say what? When the direction, when the direction of motion motion of the charge, motion of the what? Of the charge, yes, is opposite to the direction or to the magnetic field line. Look at this second case here. This is our what? Magnetic bar. This is the magnetic what? Bar. Here we have north pole, south pole. And this is our what? Magnetic field line. And if I place the what? The charge. This is the charge here. And its phase what? This is opposed. You can see this one is negative. Negative is what? Is opposed. The direction of what? Of motion. If is what? The charge here is what? Is opposed. The charge you put here, it can still put this one what? Positive. You do the same thing. Maybe that way. The charge, if the charge you put here is what? Is fed the same what? Is opposed or opposite side to the magnetic field. This is the direction of magnetic field. Facing this side. The charge moving along this side. Abi, if that be the case, the angle here, our theta here, is equal to what? 180. If two line, I go on a straight line, is 180. So from there, we have what? F should be what? QBV sine angle of what? Of 180. If we press it, we also get what? 0. Note that what? When the direction of the motion of the charge is opposite to the direction of magnetic field, the magnetic force there is also what? 0. Yes, it will make two cases. Now, what's in the cases? We have case what? Case 3. The case 3 states that when the direction of what? Of motion is perpendicular to the direction of the what? Of magnetic field. Yes, case 3 starts what? When the direction of motion of the charge is perpendicular to magnetic what? Field. What happened? Let's check the case here. This is magnetic bar. This is magnetic bar. What do we have here? We have north, we have south. Let's draw the what? This line. These are what? Magnetic what? Field. But if is what? The charge is here. And this is the what? Direction of velocity of the what? Of the charge. You know, is perpendicular to magnetic what? Magnetic field. This is magnetic field. And here we note at what? Our theta here will be what? The theta for the perpendicularity, theta will be 90 degree. It is 90 degree. What is the magnetic force? Using QBV sine what? Sine 90 degree. Sine 90 degree is what? Is 1. You have QBV. So that is, at this case, the magnetic force or the charge will experience the maximum force. That is what? The magnetic force will be what? Is maximum at QBV. Note, at this stage is where the what? The magnetic force is what? Is maximum. In a multiple choice question, we ask. So the magnetic force is maximum when the what? The direction of the motion of the charge is perpendicular to the what? To the magnetic what? Direction of magnetic field. So, and the last case is if the charge is moving in a circular path. The last case is what? If a charge is moving in a circular path, therefore, the centripetal force will be what? Will be needed. Case 4. Case what? 4. I said what? If the charge, if the what? The charge is moving along a circular path. If the charge, if the what? The charge is moving along a circular path, then the centripetal force, yes, centripetal force is what needed. What is the centripetal force? The centripetal force is F equal to the what? mv square over what? R. This is the radius of the circle, the speed of what? Of charge. This is the mass of what? Of charge. If you have this, you can call this equation what? 2. No, this is equation 2. Call this equation 3. You can now say from equation 1, from equation what? 1, where F equal to the what? Q B V, or from equation 2. Yes, let us equate the what? The F together. By equating the what? The F, we are going to have Q what? QBV equal to the what? MV square over what? Over R. Good. Equate these two together. By doing that, note that is what? This V is velocity. This one we cancel one here. We have what? BQ equal to the what? MV over what? Over R. Abi? And again, from circular motion, we all know that what? Recall where velocity equal to the omega R. Omega is velocity over what? Over R. From circular what? Circular motion. Let us put it here. From there, we can have what? BQ should be mass. What is V over R is what? Omega. Will be half mass omega. From this expression, we can later have what? The omega should be what? BQ over mass. This is what? Another equation, which is called equation what? Equation 4. Good. Says angular velocity of the charge along a what? Circular path is magnetic flux density, the charge himself, and what? The mass of what? Of charge. And yes, you may ask to find the period of motion, so of the charge along the circular path. So can I say what? The period of what? Of motion, period of motion, yes, is therefore given as, if you from the SHM, we all know that what? Period is what? 2 pi omega. So by substitute for this omega here, we are going to have, we have 2 pi m over what? BQ. Finally, the period here is be what? 2 pi m over what? BQ. So this is what? Equation 5. So that is all about magnetic force on a moving charge. So I would like, before we call it a day, I would like to solve like 3 to 4 questions on how to apply this formula. So let us solve these 3 questions on magnetic force on a moving charge. So solution. We are given that what the proton of charge this. So our charge Q here is 1.6 times 10 to the power minus 19 coulomb. Move through this. The velocity of charge is what? 2.0 times 10 to the power 6 meter per second. Perpendicular. Good. When it's perpendicular, we know that what theta is what is 90 degree. Good. Magnetic field. Magnetic field density in Tesla is what is magnetic force? Force is what is unknown. Good. What we do now? If we apply our what? Our force. Apply. Say what? Using F equal to what? Q BV sine what? Sine theta. So let us apply the formula. What are we going to end up to? We have magnetic force should be Q is 1.6 times 10 to the power minus 19 multiplied by what? V 0.3 multiplied by V 2.0 times 10 to the power 6. Then sine what? Sine 90. Sine 90 will give us what? 1. So if you multiply everything, your final answer must be what? 4.8 Newton. So look at the second question. We are given charge. Solution. Our charge Q given is 0.5 multiplied by 10 raised to the power minus 6 coulomb. Good. Move with a speed of what? 3 times 10 raised to the power, this V equal to what? 3.0 times 10 raised to the power 3 meter per second, parallel to the magnetic field of this. B is 0.2. This, what is magnetic force? Our force is what? Q BV. It's parallel. When it's parallel, please, what will be the theta? Theta will be 0. Abi now? Or 180. So we have sine what? Sine theta here. By substitute for each value here, we will have what? Theta will be 0 or 180 because it's parallel. Yeah. What is Q? 0.5 times 10 to the power minus 6. What is B? 0.2 multiplied by what? 3.0 times 10 to the power 3. Then sine what? 0. If multiply everything, you get what? Your final answer here must be what? 0. Since it's parallel to the what? Magnetic field. I proved it for you before. So let's solve this last question. Yes, this last question is sweeter than everything. Solution. We are given velocity. The velocity given here is what? V, which is what? 2I plus 3J minus 2K. Everything in meter per second square. Good. And we are given what? Magnetic flux density should be I plus 2 is plus 2K, which is what in Tesla. Abi? Good. We are given the 2. We are now asked to find the what? Out of charge. You must give out the charge. Yes, charge is 10 coulomb. Good. And Q for charge. The charge is what? Is 10 coulomb. Charge is what? 10 microcoulomb, which is what? 10 times 10 to the power minus 6 coulomb. Good. We are looking for what? Force. The force F will be Q into what? B multiplied by what? This. This The reaction relationship between what magnetic flux density and the speed of charge is cross product. So if it's a cross product, we are going to have what F should be what? This charge is what? Is 10 times 10 to the power minus what? Minus 6. So everything you have here, you need to take it to what? To the determinant of matrix. By putting the determinant of matrix, what are we going to have? We have what? I, J, K. Yes? So the first value we have here is what? Is 2, 3 minus 2. Here we have 1, 2 plus 2. Then the next thing is what? We need to apply determinant what? Method for this. So the force F, this force F is going to be what? Force will be going to be 10 times 10 raised to the power minus 6, yes, into this. We are going to solve this in what? In a determinant form, which is what? I, put I, yes, into this, then this is what? Plus minus plus, then minus J into this, then plus K into what? To this. So if you are doing that, okay, take I out. So opposed to the matrix of determinant, take this I out, you are left with what? 3, 2, 2, minus 2. Take this J out, we are left with what? 2, 1, and minus 2, minus what? 2, and what? 2. Take this K out, that is what? 2, 1, 3, 2. Okay. So the next thing here is what? Our force will be 10 times 10 to the power minus 6. Yes. Minus what? 6. Good. Into bracket what? Into bracket this. We are here. Multiply it. 3 times 2, 6. 6 minus, you have what? For this no, this way. 6, wait, let me do this one in this form. 2 times this, we have 6. Then 2 times 6, 4. Minus, plus 4. Good. Here we have what? I. Then we have what? Minus. Minus for this J. There are 2 times 2, 4. Minus times minus 2. While this one, plus 2. We have it in this form. And here we have what? We have J. Yes. We are left with what? Plus K. 2 times 2. We have 4. 2 times 1 minus 3. Good. We are left with what? With K. Good. So bring this what? Down. By doing that, what are we going to have? We have force equal to the what? 10 multiplied by 10 raised to the power minus 6 into this. There are 2 times this. 10 plus this, we have 10 I. Are we? Minus this will give us what? 6. This give us what? Plus K. So here we have what? 10I. Here we have what? Plus 6J. Here we have plus 1K. So this will be the what? The force in thing. The second question, we are now asked to find what? Question B, to find magnitude. So the magnitude is very simple. Magnitude will be what? Magnitude of the force is this. That will be what? T raised to power minus 6. Yes, I'm going to find what? The square root of this value here. Find the square root of this value and I will square them. Okay, we will square them. Well, let's square it. 10 square minus 6 square plus 1 square. So if we square everything, add it together, final answer will be what? F for this will be 1.17 times 10 raised to power minus 4 Newton. This is the magnitude of what? Of force. So these are the what? The kind of question they can ask you on magnetic force of a moving charge. So in the next class, I will continue for magnetic force on a current carrying conductor.